Welcome back, everyone. This is the 2025 Virtual Residency Workshop. It's Monday, June 23, 2025, and this is our fourth and final session of the day. So this is the Cyberinfrastructure Landscape, Systems and Organizations, and our speaker is Mike Renfro from Tennessee Tech University. And take it away, Mike.
All right. Hey, like Henry said, Mike Renfro, Tennessee Tech University, and currently Campus Champions leadership team. Off to the corner of this is seven adorable Tennessee high school students that we've had on campus for the last couple of weeks doing various things to do with HPC. I've got them for an extra week and then they leave, and maybe if we're lucky, they turn into the next generation of research, computing, and data professionals. So, to give you an idea of where I come from in all of these both of these talks that I'm going to be giving here. So my LinkedIn bio has all kinds of fancy language about having decades of experience supporting research, engineering research, and other things. And it really kind of comes down to this, that I'm a self-diagnosed, high-functioning ADHD type guy who probably should have spent more time studying than I did in computer labs helping people with various problems that they had. I happened to luck into a couple of co-op years at Oak Ridge National Lab in the early to mid 90s, doing a mix of CAD support, Unix systems administration, and actual engineering, especially the second year. And so that eventually turned into a series of degrees from my original university. I like to call that a master's in shaking things and a PhD in breaking things. Around that, I spent 17 years as an R&D engineer in a research center here, and then as the first campus-wide HPC systems administrator in central IT. I am a member of way too many research, computing, and data community groups. I have been on the Campus Champions leadership team for nearly 3 years, on the Emerging Centers Steering Committee for CARC for about a year, and I am a compulsive advice giver and rabbit hole chaser. And so, for the folks who don't have a whole lot of time for the rest of this talk, or for the new folks that could just be overwhelmed by everything that there is new to learn in research, computing, and data, let me start off and get you what other people that have done this talk before me have called basically the starter pack of RCD organizations and conferences. And you can use those as a jumping off point to find other communities and resources as you need them. And so the first one is Campus Champions. And I'm on the leadership team there, so arguably I'm biased. But I can absolutely objectively say that this was the second RCD community that I joined about 6 years ago. It's the one that introduced me to Henry and all the other folks that are helping run virtual residency and do other things elsewhere. So Campus Champions is one of the longest running RCD communities, starting around 2008. It was originally funded as part of NSF's Extreme Science and Engineering Discovery Environment, or EXCEED. Current membership last year was over 800 members. I'm sure it's gone up a bit since then. They're from every state, has folks from every role. So research, computing, and data facilitators, software engineers, systems administrators, directors, everything. Campus Champions has a pretty active mailing list and a fairly active Slack. It has two regularly scheduled calls each month. One of those calls has a specific topic and an invited speaker or several, and the other one is sort of a more free-flowing community chat over any topic of interest to the attendees. Sometimes we will start that community chat with something that's recently come up on the mailing list, other times from recent news items. Another advantage to Campus Champions is, even though we don't have direct ties to the Exceed follow-up project access, the access team does provide Campus Champions with additional insight into their own institution's use of access resources. And that can help you, as your campus's research, computing, and data staff, to help guide your researchers to either more efficient use of access resources or to more suitable locations for their work if something is just a poor fit at the first place that they thought of. Another or the other primary catch-all group similar to Campus Champions is the Campus Research Computing Consortium, or CARC. And so CARC has a pretty comprehensive structure of tracks, of interest groups, and working groups. All of these are kind of ad hoc and community driven and have come and gone, as the community has needed it. All of those tracks in the what they call the people network tend to have one Zoom call per month with a lot of behind the scenes coordination going on. Now, the biggest thing that I think differentiates CARC from any other organization is their ongoing work, and I'd say unique work, in professionalization of our research, computing, and data field that helps translate our roles into job family matrices that you can use with your human resources department to figure out how people fit into the broader university structure in terms of promotion and differentiation. There's an RCD Nexus organization attached to CARC that puts together workshops and papers that are on workforce development, benchmarking your organization against others, and also the RCD capabilities model that will assist with that benchmarking and also with identifying the priorities for improving your organization. Now, both of those organizations are all virtual, no cost to join, all very welcoming and accessible for new folks. However, if you have some budget, and this year that might be a little different for y'all than it was last year, depending on your situation. If you got some travel funding and you don't know where else to go to improve your local campus or RCD program or yourself, there's a few more options. One is the ACM, the Association for Computing Machinery, the Standard Computer Science Professional Society. They host an annual Practical Experiences in Advanced Research Computing Conference, aka PERC. And PERC is by far my top priority conference for the last few years. This is the de facto RCD people conference versus a stuff conference. We had about 1,000 people in attendance last year, even with the CrowdStrike Hoosafudge. And it's small enough as a conference where you can meet a lot of people that are doing work similar to yours and not get just absolutely overwhelmed by the scale. That conference, it's pretty much a typical academic and professional conference. There's papers, there's presentation tracks, a poster session, a visualization session where students, faculty, and staff can show off their work and get some ideas you can get ideas to take back with you to your campus. There's a whole day of workshops and tutorials on a huge range of topics. There's co-located events from CARC and RCD Nexus on the Sunday before the actual conference starts. And there's also a great student program that they have every year that I'm now sending my second student to. And so I would say go to PERC at least once in your career. But on my list, it's pretty much on the top of the list every year just because of the people that attend. Now, on the entire other end of the spectrum from PERC is the Supercomputing Conference series. Now, this is the one that your HPC conversant faculty in computer science or computer engineering are probably most familiar with. And it's probably the most famous HPC type conference worldwide. This one is absolutely enormous, about 18,000 attendees last year in Atlanta. Tons of vendors, huge exhibition space, a lot of recruiting going on for graduate programs, for national labs, etc. If you've heard of the top 500 list of the fastest supercomputers in the world, it comes out twice a year. One of those lists every year comes out co-scheduled with supercomputing. There's a student cluster competition every year where teams from all over the world compete to squeeze the most performance out of a limited power budget live on site and get the best performance out of a range of computational codes. The SciNet network that handles the Wi-Fi and the hardline networking for everything at supercomputing is an absolute technical wonder. I don't know how many miles of cable they strung around last year, but it amounted to about 9 terabits of internet bandwidth for the attendees and exhibitors. No Wi-Fi problems, no nothing while I was down there. And now for me, so far I have only gotten to spend a total of count on one day in the supercomputing exhibition hall, and I didn't go to other things. But from what I've heard, some people would say one time at supercomputing was enough for them, but you may find that you want to go back repeatedly. And so the last thing in the starter pack is where you're at right now. And so that's Henry et al.'s virtual residency program. And I am in. He's already explained what we're doing here and why, and I'm not gonna repeat that for him. But I am eternally grateful to Henry and everybody else for helping me attend this in 2019 because it was and is to me still the best value experience for RCD professionals, especially if you're at an under-resourced institution or an emerging program like I've been for the last several years. So beyond that starter pack, there are at least dozens, if not hundreds, of RCD and RCD adjacent groups, conferences, and other things that you can that you can get into. And there is overlap among different groups. They've all got a little bit different focus and priorities and structure. And so, how can you kind of make sense of them so that you can direct yourself, your coworkers, possibly your researchers, even to the right ones? Um, Sorry, I clicked away from something. And so I'm going to break up the rest of these groups by what CARC calls facings. And you may have already talked about this earlier today. I apologize for not having gone through the agenda or anything, but I've had my adorable kids with me all day today because we're having to reschedule some things with them. And so facings are the broad categories of work that any RCD professional might be responsible for. And odds are you're going to be responsible for more than one of them unless you're in a very large, well-structured, well-oiled machine program. And if you find one of those, please tell me where it is. And so facings will include things like researcher facing for your staff or your time that you spend working directly with researchers, doing training, onboarding, that kind of thing. The data facing for the work that people do in data collection, research data management, archival, things like that. Software facing for software development, for profiling and debugging, scaling things up to a supercomputer scale. Systems facing for your systems and network administrators, the engineers, the architects, and strategy and policy facing for the folks that have leadership roles or deal with institutional alignment, funding, external partnerships, the things that a lot of times the deep nerds don't want to get into. And so, from the researcher facing side, especially for introductory user training, Software Carpentry and its sister organizations offer some of the best, most widely tested, low barrier to entry training materials and instructor training out there. Now, we've used Software Carpentry materials for audiences from everywhere, from our advanced high school students, like we've got every June, every year lately, all the way up through our research faculty. And two of us here have gone through their instructor training, and that will give you new insight into the science of pedagogy and instructional design. So many of us that sort of wandered from grad school into teaching something. We were all told, here's the slides or the materials that were used the last time we taught that class, go at it. And figure it out for yourself. But there is a lot of science that goes into that, and they do cover that. The core curriculum in software carpentry is sort of your bare minimum fundamentals for people to do reproducible research. And so it covers the Unix shell, it covers Git for version control, and a couple of different course options for doing data processing in both R and Python. And like I said, very low barrier to entry, can work on Windows, Macs, Linux, your HPC, whatever. Also in researcher facing is the Cyber Ambassadors program, and I know they've got a few time slots during virtual residency, so I will let them explain themselves in better detail. But in general, they're a recognized leader in training for more of the soft skills that complement the technical ability that you or your coworkers have. They offer workshops in communications, in teamwork, in leadership, and a couple of years ago, the PIs for Cyber Ambassadors were inducted into the ASEE Hall of Fame for their work in that program. Now, moving on to data facing. And so there's the Research Data Access and Preservation Association, or RDAP. This organization is geared toward your data facing people, your research librarians, and that kind of thing. Now, me, I'm the kid of a less fancy public school librarian from a K through 12 unit school. And so being around librarians just sort of, gives me a warm, fuzzy feeling inside. RDAP just finished their annual conference a little while ago, a few weeks ago, and the QR code and the link in that QR code will take you to a full set of YouTube recordings, posters, slides, and other materials for that entire conference. You can always trust the librarians to basically adopt FAIR principles on their stuff. And so much of this is sitting wide open for people to use. And this is really valuable material that you will not find elsewhere in the RCD ecosystem. And I forgot to mention at the top of this that if you see a QR code that you like, all of those are active going to the area that I'm talking about on this slide. When you get the PDFs from Henry's site later, all of those QR codes are also clickable, so you can find things pretty easily from there. So then we got Data Carpentry, and Data Carpentry is a sibling organization to Software Carpentry, and where Software Carpentry was sort of the bare minimum, least common denominator skills for everybody. Data Carpentry focuses on building curricula for domain-specific training materials in different physical and social sciences. There is some overlap with the software carpentry materials, but not a whole lot. But data carpentry gets to be quite a bit more focused on what they cover to match the specific needs of the field that they are targeting. And then the last organization, or the last main arm of the carpentry's organization, is library carpentry. Now, this one is more geared for not for your researchers or your students, but they're more geared for your actual library and information professional colleagues in the library or elsewhere. And so library carpentry offers materials on how librarians can get more familiar with software automation so that they can promote that elsewhere at your institution and it doesn't all fall to you. This is synergistic with other carpentry's activities and can basically help your library staff provide an easier gateway to your research computing services because they may be better known or at least approached before you are in some cases. Now, for software facing, the dominant organization for that one is, at least in the US, is the US Research Software Engineer Association, or USRSE. Every time I pull their logo for this, it's always June, it's always Pride Month, and I get the Pride Month logo version of USRSE. And so USRSE is a really inclusive group where not every member is expected to be a professional software developer. I'm not. And I have, participated in a few things they do. But if you do have people who have a software developer title or a very heavily software facing role, this is exactly where you want them to be. There is so much software out there that we are asked to support, modify, or whatever that's just good enough to get some part of the job done, but it's not good enough to scale up or scale out to bigger problem sizes, and USRSE can help there. Another nice thing with USRSE is that they and the Academic Data Software Alliance put together a comprehensive career guidebook for both data scientists and RSEs, and that very nicely complements what CARC does with broader RCD professionalization. You can find that career guide in USRSE's resources page when you go through that QR code or their website. Systems facing. Now, this is kind of my home as a titled systems administrator in a research computing role in a central IT systems administration group. And so ACM's SIG-HPC Systems Professionals, which is distinct from ACM's SIG-HPC, SysPros was the first RCD group I joined probably sometime in late 2018. And so I was hired into central IT, into an enterprise systems administration group based on my systems facing skills. And even though I'd been running HPCs at smaller scales for, at that point, probably about 12 years, CISPROs showed me a whole lot more that I could be doing and let me learn from other people's both their mistakes and their successes. Now, I will tell you that demographically, CISPROs does not look diverse at all. They all kind of look like me. However, I will tell you that this is just as welcoming of a group as anybody else, and they are practically unstumpable on deep systems related questions. CISPROs has a Birds of a Feather session and a social event every year at PERC, probably has them also at Supercomputing, and has a ridiculously active and chatty Slack instance where most of the year-round coordination and activity happens. Also in the systems facing is Linux Clusters Institute, which is more of a training sort of thing for your newer or sometimes even your older HPC systems administrators. Now, I've only attended one of these workshops this spring as a last minute substitute instructor, but LCI has three different levels of workshops that they host at different times: an introductory, an intermediate, and an advanced. And those workshops are regarded as some of the best training for your systems facing people to level up their HPC administration skills. And every time there is a new LCI workshop, we have a whole bunch of people joining the SIG HPC SysPros Slack all at one bunch. And it's great to have that to help grow the community there. Now, on strategy and policy facing, there's a few groups here. And I'm going to start with the CASC, the Coalition for Academic Scientific Computation. And this is the premier group for strategy and policy facing folks in research, computing, and data. CASC has probably the closest ties to the federal agencies that drive a lot of RCD funding and do a lot of that liaison work. And as part of that, the CASC is a good channel for our communities, our institutions, to have their needs and concerns communicated back to the federal agencies. Now, there is a membership cost on CASC, unlike basically any of the other things I've talked about so far. They have changed their membership dues structure a bit to make it less expensive for the smaller universities and a bit more expensive for the largest ones. Um, and and another thing with the CASC member meetings is, I get imposter syndrome something fierce at each of those. Because the strategy and policy facing field is not my comfort zone. I am getting better at it, and even if I never did get better at it, even if I never attended another meeting, CASC fills an absolutely unique role in our ecosystem, and I am super grateful that they are doing what I can't do as easily on my own. Now, another externally facing RCD group is the Research, Computing, and Data Community Group that is part of EDUCAUSE. And depending on your background, depending on where you fit into your organization, you may not have heard about EDUCAUSE, but I will guarantee you anybody in management in your central IT organization has heard of EDUCAUSE, and you are probably institutionally a member of EDUCAUSE, even if you've never run into them yourself. And so that community group in EDUCAUSE goes a little bit farther afield than other groups that I've looked at in terms of dealing with support for the administration of research rather than just the research itself. But they do provide an interesting mixing area and niche between the dedicated RCD type groups and more of the enterprise IT folks. And then the last group I want to talk about is the Regulated Research Community of Practice, or the RRCOP. And so RRCOP is the best meeting place for any of your folks that work at the intersection of cybersecurity and research compliance or compliance in general, and the actual research that's being done. And so if your institution is just sort of getting into more sensitive research areas, especially Department of Defense research, RR can be an irreplaceable sanity check for everybody at your campus. Again, especially if this is a new area for you. Because at times, left to their own devices, people that are in charge of doing security measures can go a bit overboard compared to others in terms of how they see as caution, how they see as what they see as risk management, and how they deal with unknowns. Our RCOP, though, exists as sort of a clearinghouse for gathering what other more experienced institutions have succeeded with and what they are doing to secure their more regulated data. And I am going to now pause for just a minute. If anybody has a question, that's fine. I am basically on time with what I thought I would be. And so, okay, give me a second to swap slides. All right. Y'all seen this slide? That's a long time ago. I still have that shirt. That shirt is in a lot worse shape, and it has this weird bulge around the center area just above my waistline. It's gone defective over the last 30 some odd years. And so, that having been said, this is my talk on basically systems, providers, and technologies. And so, similar to the ecosystem and the organizations side of things, there is a huge array of all of what I call the stuff of other people's research, computing, and data resources and things like that. And so there's dozens of HPC systems that your people can get access to. There are consultancies, there's services, there's software that you can use either on site or with your researchers in sort of a SaaS sense. And rather than go into every bit of detail on every one of them and run myself out of time, as much as I love to hear myself talk, I do have, an actual agenda here. Let me start out with some resources you can use to find more of the resources that you will need to help your researchers find, and especially computational and storage resources outside your institution. There's only so much stuff we can afford, but we can have access to a lot of things at absolutely zero cost that we can leverage. And so, depending on your background as an RCD professional, possibly a new RCD professional, depending on your user's background, you might get overwhelmed by the variety of options that are out there. There's also a very high chance your users might make a suboptimal choice based on what they're just used to using. And it may not be appropriate for the new research that they want to do. And they're not going to necessarily know that there's better resources out there unless you guide them that way. And so let's start with a look at some of the federally funded resources and how you can sort of narrow things down a bit for people. And again, all of these QR codes are active to the location that I'm talking about and clickable in the PDF versions of the slides when you get them. And so the critical mass of resources funded by the National Science Foundation are going to be found in the Advanced Cyber Infrastructure Coordination Ecosystem, Services and Support, or Access. And Access's allocations portal at allocations.access-ci.org is the starting point for getting anything set up on Access, whether it's for yourself as like a pilot study for some of your campus users, or directly for your researchers. Now, the first thing Access is going to need for you to make good use of them is you need to kind of decide what kind of a project scale you want to attack. And honestly, you should probably just start with the lowest two cases or the lowest two types of projects to get started, because especially if you're a smaller organization, the scale of what you can get even on the explore and the discover type projects will dwarf what you could provide on site. Um, and so a lot of your users' use cases, even at the larger universities, can often be met with those smaller two project types. Those will accommodate classes, training workshops, NSF graduate fellowship recipients. And again, if you're a smaller institution, it can provide a scale of resources that would have otherwise overwhelmed your local facility. But the highest level of access project, the Maximize project, can also handle the highest scale of research activities, all the way out to the ones that make global news for new discoveries about black holes, subatomic particles. Take your pick there. And so, Access's procedures for getting one of these projects are a vast improvement over its predecessor, the Exceed projects, in terms of barriers to entry, flexibility, and responsiveness. And I'm not going to throw shade at Exceed for what they enabled because it was also the best game in town, but Access learned a lot of things from Exceed over the duration of the Exceed program. And so one thing that is a massive improvement for Access versus Exceed is that the all but the highest tier of allocations or project types can be submitted anytime during the year. It's a rolling deadline, and they've honestly got pretty small justification requirements. Everything from the overview, which honestly is a paragraph of text sometimes. It's not even a full abstract, okay? And 1 page and 3 page proposals that your researchers especially should not have any trouble providing at all. Um, and then depending on the type of project that you submit for, that project is then awarded credits, not that you're going to any specific location, but you're just awarded fungible credits in the entire Access ecosystem. And so those credits can be exchanged for time and resources at any Access resource provider. And if you find out later that this was not the right resource for you, you can pull back any resources that you hadn't used, exchange them back into credits, and then trade them to the next place. And so you get much more opportunity as the research computing and data staff working with your researchers to do some more exploration, see what resources work, which ones don't, and maybe make a few more mistakes without jeopardizing, research progress for your user. Now, while you're working on the documentation for the Access project that you'll submit, you can also and should check out Access's resource catalog to sort of get an idea of where you might want to send your researchers' work to. Okay, and so in Access's resource catalog, there's about 20 different services listed. And there's no way you're going to want to click through each of them one at a time and look at them in exhaustive detail. So the Access allocation site here gives you this filter option over here on the far right. That's where you and your researchers can go through and pick some sort of plain English attributes of what you're looking for and the type of resource you're interested in. And then that will filter this list on the main page down to the resources that actually match that attribute. And so, and then when you want to get more information about any of those, you can click this learn more about, pick that resource, and find out more information about those more detailed resources. And so I'm going to give you a brief overview of some of the newest and maybe the most interesting resources. Some of them just have new updates, but by all means, use the filters and look through these things to find what works best for your folks. And worst case, if you have trouble, reach out to Access, reach out to Campus Champions, to CARC, to any of these other organizations that I've talked about before to get advice on where you might want to go. And so one of the newest systems in terms of actual launch date is Delta AI. Delta AI is at the University of Illinois Urbana-Champaign's National Center for Supercomputing Applications, or NCSA. Now, NCSA, it's probably a matter of opinion, but at least for me and what I was aware of at different points in time, NCSA was the motherland of academic supercomputing for me. And so the new Delta AI system they have is very GPU heavy for any kind of accelerated simulation, but especially AI, deep learning, and similar applications. This is using the NVIDIA Grace Hopper, the ARM and GPU super chip, exceedingly high bandwidth between the CPU and GPU. And that's a lot of resources there that just launched, I think, in November of 2024. Now, Delta AI's predecessor, Delta with no AI, is also pretty GPU heavy. It's a few years older. It's not the absolute latest, most bleeding edge GPU hardware. But if you look at the simple scale of how much they have to offer, they have on the order of 800 plus ampere GPUs. Some are better for training than versus for inference. But that's a massive scale of things and is nothing to turn your nose up at. Now, TAC, the Texas Advanced Computing Center at the University of Texas Austin, is also an absolutely massive installation with Stampede 3. Stampede 3 has over 1,800 individual compute nodes, a mix of Intel and NVIDIA GPUs. They added on some of the NVIDIA H100, similar to Delta AI recently, but not quite at the same scale that Delta AI has. And so they've got high bandwidth memory machines, they've got high speed networking. They are absolutely ready to take your application runs that need tens of thousands of cores of scale, but they will also take smaller size jobs. They will also take high throughput jobs that maybe even are down to like single node, single core possibly, and still take that work happily. And so Stampede 3, the main bulk of it, launched in late 2023 and is a successor to TAC's earlier successful Stampede and Stampede 2. And these H100 GPUs, I think they literally got them installed and announced within like the last 3 weeks or so. So brand new set of features for them. Another one that's pretty big in the Access ecosystem is the Pittsburgh Supercomputing Center, PSC. This is jointly managed by Carnegie Mellon and the University of Pittsburgh. And their primary center that they have is called Bridges 2. This is a very long-standing resource in both the Access and the Exceed programs, and possibly before Exceed, but that's before my time. Not everything in Bridges 2 is the most bleeding edge hardware. These facilities are not typically doing yearly or every 2 year upgrades. But for certain applications, even though they're a bit older, their extreme memory nodes that have like 4 terabytes of RAM each are absolutely invaluable, irreplaceable anywhere else in the ecosystem. They also recently beefed up their GPU capacity with some new machines that have 8 of the H100 GPUs each. And so Bridges 2 has been, my go-to resource anytime my users have outgrown what I can do here locally, or in the unlikely, but it's weird that it happened once event that a backhoe takes out all of my data center's power that causes a weeks-long storage outage a couple of years ago. I have stories. Another one that's also fairly recent, but also serves a bit more of a niche purpose in the NSF, is the Derecho cluster at the National Center for Atmospheric Research, or NCAR. And so the thing with Derecho is they have several GPUs there. They got, about 300 A100 GPUs, similar to the 20 that I've got. But what they do have is they have 300,000 plus cores that they can throw toward a CPU heavy job that doesn't have a lot of GPU support in it. I think that is probably the single biggest system that's available through the NSF process. CPU capacity, one of the main differentiators there. And so, they are focused on, atmospheric climate and other Earth system processes, though they are not a catch-all for all research, but I think they will take outside that area, but it's not going to be their top priority necessarily. But if you need a lot of cores, Derecho might be the way to go. Now, Anvil at Purdue, uh, so Purdue's Anvil system, they've actually got a few different things branded Anvil. And so they have a CPU set of nodes, they have a GPU set of nodes, they have large memory. They also uniquely have what they call the Anvil composable subsystem, which could be computational, but could also be purely infrastructure. The composable subsystem at Anvil basically gives a Kubernetes management and orchestration layer for certain workloads. That could be for your science gateways, it could be for other things. Uh, but that is unique to have a one-stop Kubernetes resource in the Access ecosystem. Everything at Anvil that I found is, third gen AMD 128 core each, anywhere from 256 to a terabyte of memory, and a few nodes at least with A100 GPUs. Now, on that same vein of things that aren't purely compute, but are still critical for certain research applications, is Jetstream 2 at Indiana University predominantly. They've got a few offshoots elsewhere, but the bulk of their resources are at Indiana. And Jetstream is intended to provide a hybrid private cloud environment that's focused on demand cyber infrastructure or just infrastructure needs. Now, on the back end, this runs OpenStack. And so the prime use of Jetstream is to make long running VMs for whatever research purposes you have, whether or not those VMs have computationally intensive workloads. And so that could be, vector databases for your LLMs. It could be all kinds of things. And so, but if you have something that is both, not exactly HPC, but still computationally intensive, the Jetstream nodes are pretty dense on CPUs and GPUs. Now, personal anecdote, I used Jetstream 2 for a workshop I gave at PERC last year where I needed to stand up 30 something OpenHPC clusters, one for each participant, and talk about how to administer OpenHPC. I hosted that on Jetstream. I absolutely would not have been able to conduct that workshop in any other feasible way other than with them, and they have a huge amount of thanks to me forever as a result. Now, the last thing I want to talk about in NSF and Access is the ACES facility at Texas A&M. Now, this one is quite a bit different than the earlier systems that we've talked about because ACES niche is in software-defined architecture and the composability of various resources more than just raw compute power. They got 12,000 cores, but that's not huge on the access scale. What they do have is a mix of Intel and AMD CPUs, but the main draw at ACES is this huge range of accelerators, well beyond GPUs. FPGAs, coprocessors, vector engines, intelligence processing units, all kinds of stuff like that. And they have the ability to share a lot of those accelerators across nodes so that you can basically software define a node that has both an FPGA and an intelligence processing unit and other things all at once without the hardware literally having to sit in that computer. And so if you've got some particularly uncommon use cases in computer architecture, ACES is definitely a thing you want to be aware of for those folks. Okay, now the other main agency I think of at the federal level when I think of scientific research and high performance computing and research computing is the Department of Energy. Oak Ridge National Lab is about a 90-minute drive from where I'm at right now. And my university has had good relationships with them for years on graduate programs, collaborative research, and other work. And so Oak Ridge's leadership computing facility, the one that has, whatever Oak Ridge's fastest supercomputer is part of DOE's Advanced Scientific Computing Research Arm, or OSCR, ASCR. And so, if Access is not the best fit for what your researchers are doing, and especially if there is an alignment and interest from DOE in what your researchers are doing, you absolutely should give OSCR a look in addition to Access. There's four main avenues into OSCR resources. Each of them has their own little niche and access to different facilities. And so, for example, Insight is based out of both Oak Ridge and Argonne National Labs. This is suited for open science applications that can scale out to use the majority of a top 10 global HPC environment. So massive scale supercomputing. The Oscar Leadership Computing Challenge, the ALCC, can help a project out on a year-by-year basis if that research aligns with DOE missions, or if it broadens the community that could make good use of the HPC facilities at either Oak Ridge or Argonne or the NERSC at Lawrence Berkeley National Lab. The ERCAP is for projects that have SBIR and STTR relationships, the things that are on the road toward commercialization and outside the university, that also align with DOE Office of Science priorities. And then each of the three main centers at NERSC and Argonne and Oak Ridge, there's always about 10% of the CPU hours, I think, per year are left to each facility center's discretion into what they call the center reserves category. And all of those programs are linked in blue in that PDF there, and then the main Oscar page is in the QR code there as well. And then last but not least, on resources and infrastructure that's available to you and your researchers are the ones that fall under the umbrella of the recently launched National AI Research Resource, or the NAIR pilot project. And so in a lot of cases, the the federally funded resources that are under the NAIR umbrella are actually the same resources that you get through Access or through Oscar. Okay. And Access or Oscar or some other route to those same resources might actually be a better or an easier fit for your researchers. We've been at a NAIR meeting, earlier this year where, there was a sort of a disconnect and maybe a little bit of a bureaucratic barrier between the NAIR people and the Access people, or what they were willing to talk about. And I think that has been eroding away, and they're more collaborative now. Um, but the main thing that NAIR has that Access does not have is that NAIR has donations from over 25 different non-governmental partners all over the AI and cloud hyperscaler market. Okay. And so if your researchers need to go beyond the hardware provided by Access, NAIR is absolutely invaluable because of those commercially funded models, inference services, SaaS offerings, and hardware offerings as well. Okay, on to services and consultancies. And so Access has a few different options here. The first one is the Match Plus program. And so Match Plus can be an absolute lifesaver for the under-resourced research projects or for new users. And so Match Plus, they take requests from a researcher that has a need for some kind of computational help and matches them up with a student and a mentor so that the student, wherever that student is, can provide that kind of support. A Match Plus engagement typically runs for 3 to 6 months, 5 to 10 hours per week for the student, and maybe 2 to 3 hours per week for the mentor. And so from that, a researcher's project could be scaled up from desktop scale to an introductory HPC scale. They could identify some bottlenecks and some optimizations to be made, or they can get extra assistance migrating that workload from a smaller HPC up to an larger scale access resource. And the nice thing with the Match Plus engagements, they have absolutely zero charge to the researcher So do take advantage of them, where appropriate. Now, for a project that's established, that has a budget and funding, and has different needs, there is a higher tier called Match Premier. And so this is better suited for projects that could benefit from a postdoc or a research scientist, but your institution might not have those people available in the specialty that that project needs them, or at least may not have them available on a schedule that that project that they can make use of. And so match premier engagements are paid engagements between the benefiting researcher and that expert consultant. And Access primarily just facilitates making those connections more than it does than it would for the Match Plus, where it has a more active role. Now, the EPOC, the Engagement and Performance Operations Center, this may not be as appropriate to an individual researcher as much as it is for your RCD organization or for your campus as a whole. But EPOC basically consults on reducing bottlenecks in network performance, in data transfer, in similar areas. And so they offer a roadside assist, what they call a roadside assistance service, to reactively troubleshoot some network problems. They also offer what they call an application deep dive to look closer into application workflows, into science DMZs, and other areas to sort of evaluate where bottlenecks and potential capacity issues might be, and do that in a bit more proactive fashion. And EPOC, I don't remember how to pronounce it now. Also, they provide some network monitoring tools like NetSage that can help you also yourself more proactively discover and resolve performance issues. Science Gateways, the Science Gateways Community Institute and the SGX3 Center of Excellence. Those both provide an invaluable resource for your software facing folks beyond what USRSE does. And so science gateways are normally web-based interfaces. They could be API-based interfaces, but typically interactive web interfaces to computational resources. And those can greatly reduce the barriers to entry for those resources, where instead of your molecular dynamics researcher having to provide a shell script and a bunch of other things, that you can basically give them a more guided way to get their simulations done, for example. And so Science Gateways folks, they've got interests in workforce development, broadening the community to use research computing resources, providing expert advice, and basically steering future software and gateway development practices for the good of the whole community. Now, for tools and software, this is a fairly short section here. The Open HPC project, I know I've got a question in the chat about it that I'm going to respond to here in a minute as soon as I'm able to. But Open HPC has been an absolute lifesaver for me at the time that I needed it. Okay, and so Open HPC provides a completely free and open source suite of components, actually several completely free and open source suites of components to build HPC architectures with a minimum of effort. And so I have had every one of my student workers since 2021 build a virtual open HPC environment on their university issued laptop. And every one of them has managed to get a running HPC architecture up and running within about one full working day, sometimes with a little bit of advice. And so if your HPC environment was a turnkey vendor product and it's running out of its support life cycle, or license terms have changed or whatever, OpenHPC could give that cluster an extended lifespan. It can also let you focus your budget on hardware and on people rather than licensing fees for those environments where that budget trade-off makes sense. Another tool I want to call out is OpenXD Mod. This is from the University of Buffalo, and this is a unique tool also used in the Access ecosystem overall for everybody, that can really help you quantify and explain your HPC's usage trends and communicate that to the individual researchers, to your management, other leadership, and other stakeholders. And so for me, as you know, the got to do everything guy, and dealing with the PIs and the faculty where their students, aren't making the progress that they might think they should be. OpenXD Mod has let me stop so many conversations that the faculty started with, well, my students aren't getting enough access to the cluster. And because we could look at the data in a very easy to read fashion, we could turn those conversations into a much more productive direction in terms of there's plenty of capacity for your students. If they're not making the progress that you think they should, let's discuss that in something that's not a resource constraint conversation. And so XDMod, OpenXDMod, completely free and open source, long history of development and support. And this is one of those things that when you get it set up, it makes your center look so much more professional, especially if it is under resourced. Or well, it's a bigger benefit to the under resourced folks. Um, Open On Demand is another one. This is from Ohio Supercomputer Center. This one is, I think, second to none in making a lot of your HPC access much friendlier for new users, and experienced users may like a lot of it too. And so if you haven't seen it before, Open On Demand can give you a web interface to your HPC users' files, whether that's individual or project files, web-based terminals to your login systems, job monitoring, graphical access to your cluster nodes for workloads where that makes sense. And you can build or use other people's existing application forms to streamline common computational tasks. And so we've got one that helps people set up Jupyter notebooks the way that they need to. Your security people are going to be happy that you can secure open on demand behind the same multi-factor authentication that you use for everything else on the web at your university or your institution. And you will almost certainly hear good things from your users about open on demand as well. And so the last tool I want to get to is SPAC. SPAC provides a framework and provides tooling for building software packages. And so this integrates with the module system that you might already be using to let people swap in and out different software packages on an on-demand basis. But SPAC also makes it much easier for you to support optimized builds of those computational tools compared to what you might get with the old standard /configure make install set of commands. The SPAC folks have been offering full day workshops at PERC. All of that training material is online, but attending that workshop in person for me and one of my other folks here was absolutely invaluable in getting past a few hurdles to have the actual upstream developers there to answer questions. And so that is all that I've got. I think I actually finished about 15 minutes early, but that means there is time for questions, right? So let me scroll back. Okay, thank you, Vinod. I look okay for where I'm at. I don't know that I look great as a still. Campus Champions, very nice group. Yep, Jeremy. There is a first-time attendees for PERC. Joe asked, we have a cluster with RHEL 8 and Bright cluster management. Would OpenHPC replace the RHEL 8 or the Bright? And the real answer is it would replace Bright. We were on Bright 8 as of 2017. And when I got a new cluster purchase through NSF in 2021, we we had a physical Bright machine. We then built a virtual OpenHPC management system and hooked all of our new nodes up to that from day one. And then we gradually moved all of our old nodes that were on the Bright system that we purchased around 2016 and merged them over into our OpenHPC environment. OpenHPC, when you check their if you check that QR code there, and you find their install guides. They officially support Rocky, Alma, uh, OpenSUSE, and I think that might be it for the operating systems. Uh, Currently, well, there's ARM support in some of them. There is also you can pick if you want to do Slurm or I think OpenPBS, and I can't remember what if there was a second one. And yeah, so you can pick your RHEL-like operating system, and RHEL itself should be fine too. Uh, you pick your operating system, pick your scheduler, and somewhat pick your provisioner. Probably the vast majority of OpenHPC people use Rocky or Alma, version 8 or 9, depending. They use Slurm and they use Werewolf, either version 3 or version 4, depending. Chris already kind of answered that, but there we go. Vinod said, "I'm a fan. Yes, I'm a big fan of OpenHPC. Now that NVIDIA has made Bright free, what will you choose if you were to set up a new HPC cluster today?" I might still say I would go with OpenHPC, but I probably would have to at least evaluate Bright again. But Bright's licensing in the 2021 timeframe was completely different than what we had before, and it was just a non-starter. Um, Okay, does OpenHPC support IPv6? I would have to check on that. I think it's really going to be a matter of does your operating system support IPv6 and possibly does your provisioner, whether it's Werewolf or something else, support v6. We just run a private set of addresses for v4 pretty much is what we amount to, and it's generally non-issue. OpenXDMod. No, researchers would not install OpenXDMod themselves. That is a systems administrator job on the cluster. Reasons for that include that it is a persistent web service that your individual end users probably don't have the ability to stand up. Two, it would need deep, deep read access into the Slurm or other scheduler, but I say Slurm for us, accounting database that your users would not have, but your systems administrators that set up Slurm would have. So I would say OpenXDMod is similar. I would say similar to Slurm in that your systems facing people are going to be the ones that are going to have a heavy role in setting that up. What else? And I'm also perfectly happy to hear y'all's, sweet accents of whatever they are. I love hearing myself talk, obviously, but if anybody wants to unmute and ask me something directly, that is also just fine. Does OpenHPC have commercial support? OpenHPC itself does not. Um, some of the underlying, so our IT department does not allow us to do open source. Joe, I might want to have that conversation, separately at some point with you. You can find me anywhere just about. Um, I would be really interested as to the actual rationale and limits on the not using open source. Um, I would imagine there is a company, Control IQ, CIQ. I can't remember if it's CIQ.com, but they are the prime company behind Rocky and Werewolf. And so Rocky Linux and the Werewolf provisioner. And so I would say they could probably cut you consulting on just about any, or consulting and support on just about anything HPC related. Slurm, you can get commercial support on from SCEDMD, the Slurm, the Slurm vendor. Yep, 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 Joe, that is CIQ. Um, okay, that looks like an option then. Any option on TAC or any comment on TAC stats, asks Feng. And I will admit, the first time I've ever heard of that. So let's see what that looks like. Um, It does at least have some support recently. Is there a proper website for this? So, Jianfeng, I am not sure. It looks like it might compare, but there's not enough information on this GitHub for me to give it an honest evaluation. But, sometimes resource monitoring and analysis is something that you use to help that's like not cluster wide, but it's like on a job by job basis. Okay. Thank you, Jean Feng. So I would say yes, in general, this does look a lot like what XDMod would offer. Um, if John Feng, if you haven't seen it before, if you look up Access and XDMod in Google, you will find a live version of OpenXDMod that is going across various systems in Access. Again, I'm just saying this as somebody who can find this page, and I've used it a bit before, is I can drill in here and filter for a PI institution. It'll show you the top 10, but then I can also filter for Tennessee and find my university. There's no data recently, so let me go to the last 2 years. And so then I can see who is it. And unfortunately, for the purposes of databasing, uh, this faculty who is currently at University of Rhode Island is no longer at Tennessee Tech, but they still got her tacked in under us for some reason. She used to be here, but not for the last few years. But you can basically do a real good drill down into different resource usage in there. Okay, there is additional conversation on, yep, base command manager available for free up to 8 accelerators per NVIDIA GPU accelerator and others for any cluster size. Yep, and that is a radical departure from when I left Bright, where they were basically going to charge me per GPU. And going from 4 GPUs to 20 GPUs on our second cluster made that a non-starter at the time. What else? Being an is this a requirement for all the resources? So yeah, Jeho, for access, I think the answer to that is generally yes. Somebody there, Henry, do we have people from Access showing up this week to talk Access specific things?
No, I don't think so.
So, Jeho, I'm pretty certain that by default, Access is open science. The DOE resources absolutely do not have to be open science. In fact, some of them absolutely are not going to be open science that align with some of their missions. Um, and there's probably also opportunities with the federally funded areas that are related to that particularly non-open field. So like NIH might have some resources. I know NIH has some things that they're facilitating with NAIR. I know there are people that do defense type work either around Mississippi or some of the other facilities. But at least for access, I think the default is open research. I'm just seeing if there's an obvious thing in. They do have a mention of complying with all regulations, including HIPAA. Um, but yeah, I would say if you do an access thing, if you when you first look at an access project allocation, make sure in your comments that you do note if there's anything that is not open science, and then they probably can probably aid you on that. It might be that if it's, it can be closed and, up until a paper gets published. There's probably different options, different places, or they should be able to direct you somewhere more appropriate. And yeah, Tim from Internet 2 says Access has open office hours. Uh, Looking for those real quick. Tim, if you have a link to the office hours, go ahead and throw them in there. If not, I'm going to be looking right now. Yep, NAIR's office hours I have found. Again, nairpilot.org was in the slides, but if you go most of about halfway down the Nair Pilot page in the what's happening, there's office hours that are second Tuesday of each month uh, at 3 Eastern. I know there's some Nair stuff that can handle HIPAA and other certain regulated research. But again, guess what? Our RCOP on my people ecosystem slides, if it's regulated at all, our RCOP will have somebody that knows about it and knows how they were able to deal with that kind of research. And that is there. And Tim has found the office hour links for via Access's training page. And so 4:28 p.m., my watch is saying that it's low on battery. I'm reminded of a meme image I saw today that said, "Oh, you're going to give me 2 minutes of my life back." Well, thank you. Now I can finally pursue all of my passions. And so I'm not going to be, the one who says I'm going to give you 2 minutes of your life back. Vinod, when I switched from Bright to OpenHPC, it was close enough to a forklift upgrade, basically. I just used new hardware, reprovisioned everything from scratch, and after I had everything running on my new equipment, and I started on virtual nodes to get started. But once we built a few VMs for computational purposes, just to verify things could provision and boot correctly, then we brought over our new machines that had never been on Bright. And then later, once we were comfortable with it, we brought over all of our old Bright machines. But I would not call that an in-place upgrade by any means. It was a complete switch over. Okay. Thank you, Vinod. And thank you to everybody else. And I will hang out at least a bit. Um, and hopefully I will catch some of y'all later this week, perhaps.
All right.
Stop
Thank
sharing.
you so much, Mike. That was fantastic and very valuable for all of our participants, all the virtual residents. I very much appreciate it. And I want to thank all of you. Let's give Mike a virtual round of applause. And we're wrapping up now. Tomorrow we start at 9 a.m. Central. That's 10 Eastern, 8 Mountain, and 7 Pacific. If you're in Alaska or Hawaii, it's sort of in the wee hours. Sorry about that. If you're overseas on other continents, probably even worse. But thank you so much, everybody, and we'll look forward to seeing you bright and early tomorrow morning for day 2 of our workshop. Y'all have a wonderful evening.